Could a fish out of water see clearly? Let's first consider the opposite scenario, a human underwater. When Harry Potter has to save his best friend, Ron, from an underwater hostage situation without equipment, he seeks out gillyweed, a magical substance that enables him to sprout gills and fins. But if you've ever opened your eyes underwater and experienced just how blurry things look, you'd agree that what Harry really could have done with was a pair of fish eyes. Fish manage to navigate through tiny spaces, find food, avoid predators. Their underwater vision must be good. So what makes the fish eye more suited for underwater vision than ours? And if Harry and a fish exchanged roles, would that fish be able to see clearly above water? Let's first go through why we can't see clearly underwater, then why a fish can, and use what we learned to figure out what a fish out of water would see. In order to see clearly, our eye focuses light into an image that lands onto the retina, the light-sensitive tissue in the back of the eye. Focusing an image requires bending rays of light, and the eye has two optical elements that do this. The one that people generally associate with focus is the lens. Makes sense. Lenses play an important role in focus for photography, and the eye is often compared with a camera. Despite this conception, the lens actually isn't the main focusing element in the human eye. Our lens is important for adjusting focus, but it's the transparent front of the eye, called the cornea, that accounts for most of the focusing power in our eyes. So why is that? Well, light bending, or as physicists say, refraction, occurs when light meets an interface between two different materials. Since the cornea forms the interface between air and the eye, it bends incoming rays. Now, light isn't refracted the same amount at every interface. All materials have a unique refractive index that describes how light propagates through them, and the bigger the difference between the refractive indices at an interface, the more light bends. The cornea has a very different refractive index than air, so it bends light quite a lot. In contrast, the liquid between the cornea and the lens, called the vitreous humor, has a very similar index of refraction as the lens, so the cornea bends light more than the lens does. This explains why our vision underwater is so poor. The new water cornea interface hardly bends light at all, and our lens is limited in the amount that it can compensate. As a result, light rays converge behind the retina instead of on it. This condition is called farsightedness, in which distant objects appear clear, but close objects appear blurry. But wait a minute, if we're farsighted underwater, why aren't fish? The answer lies in the lens. Two features of the fish lens distinguish it from ours. First, the fish lens has a much higher refractive index than ours, so there is more bending at the vitreous humor lens interface. Second, the shape of the lens makes it even more powerful. Something that I didn't mention before is the greater the curvature of an interface, the greater its focusing power, and the fish lens is nearly a perfect sphere, as you can see. The combination of the fish lens's high refractive index and its curvature give its eye enough power to focus an image onto its retina. Now that we understand how human and fish vision underwater differ, back to the original question. Would a fish out of water see clearly? Well, if a fish were brought out of water, its weak water cornea interface would be replaced with the strong air cornea interface, increasing its focusing power. But the focusing power of the lens would stay just as strong. This would make the light entering the fish eye too bent, so images would be formed in front of the retina. This condition is called nearsightedness, in which close objects appear clear, but distant objects appear blurry. We could always correct this by giving the fish glasses or some water-filled goggles. So, in summary, things look blurry underwater to us because in a watery environment, the optics of our eye make us farsighted. Fish are able to see clearly underwater because of their lens. The fish lens has high focusing power because it forms an interface with a material that has a very different refractive index, and it's very curved. Out of water, the fish eye would focus light rays too much, making the fish nearsighted. This would make driving around tough, but on the bright side, at least he could read.